shrink gradually. But the ice is changing well ahead of schedule. Visit a village like Uummannaq on the west coast of Greenland and you can see the impact of those changes in many different ways. For starters, each year the sea ice is melting earlier.
This is the harbour. Thing is, although you can see that most of the boats are still frozen in, the sea ice has just begun to melt. In fact, the first fishing boats of the year left here yesterday. Thing is, this is mid-May. 5 or 6 years ago, the boats wouldn't get out this harbour until the middle of June. Over the last few years, the spring breakup of the sea ice has moved forward almost a month.
You can really experience the effects if you travel out on the sea ice in spring.
Now we tend to think of snow and ice as being a barrier to travel, but for the Greenlanders, this is a vast open road. And all these bumps and lumps of the ice is because it's starting to break up. It's a spring, and this is a really dangerous time of year out in these canoes. And every so often you come across these deep cracks in the frozen surface where there's these open stretches of water. I get a horrible fear he's going to go for a run for it. This is the Inuit version of The Great Escape when Steve McQueen leaps the fence. Yeah, ready? So he's just going to rev this up and we're going to get straight over. Oh, that's the plan. Here we go! No! I tell you, it's salt water. Oh.
The earlier melt isn't unique to Uummannaq. Across most of the Arctic, the spring melt has been getting earlier since the 1980s. And it's not just that the melt is starting earlier. Scientists now know that the sea ice has been getting steadily thinner for the last 30 years as well. Yet it's only because of a bizarre historical fluke that we've any long-term records of sea ice thickness.
For decades, American and Russian nuclear submarines prowled the waters that are a few metres beneath my feet, playing a game of hide and seek beneath the shifting sea ice. From the ocean depths, they measured the thickness of the ice.
The submarine Nautilus on the first transpolar voyage from Pacific to Atlantic Oceans. A continuous record of water depth and ice thickness is obtained by the Nautilus safely on its silent and visible cruise below polar ice, which is on an average 12 feet thick, with some ridges extending down 50 feet and even farther.
This was the Cold War, and the Americans were convinced that the Russians had submarines that could break through the ice and potentially launch a surprise nuclear attack. But crucially, it depended on how thick the ice was.
So for over 30 years, the military kept detailed secret records of the ice thickness. Then, when the Cold War ended, the American Navy invited civilian scientists to join their missions. Once more, they headed under the pole, measuring the thickness of the ice as they went.
What they discovered was that the ice was 40% thinner than it had been when the measurements were first taken. It had gone from an average thickness of 3.3 metres, which is the height of this face of an iceberg, up to about just over my head, down to a height of about 1.9 metres. In other words, in 40 years, it had virtually halved.
It was an astonishing change in such a short space of time. But it wasn't just that the sea ice was getting thinner and melting earlier. There was also a third change. There was a lot less of it. Over the last 30 years, satellites measuring the extent of summer sea ice have recorded its decline. By 2005, the sea ice had shrunk by almost 20%. And by 2007, it hit a new record low when an area about 10 times the size of Britain disappeared. Scientists have put all these changes together, the earlier melt, thinner ice, and a reduction in the extent of sea ice, and some now fear that within a little over a decade, sea ice could vanish in summer altogether.
Rapid climate change is already happening here. The reality is that we may be on the verge of crossing a threshold into a world where the Arctic is ice-free every summer.
And if that happens, could it lead to a further acceleration in warming? Even help cause a sudden leap in temperatures like the one at the end of the Younger Dryas? The truth is, no one knows. And there's the rub. The models say global warming will be slow and steady, and that's bad enough. But the lesson from history is that when change comes, it can be very sudden. To get some idea of what rapid climate change can mean for a society, I've come to the Four Corners region of Southwest America. It's a harsh environment. In summers it's dry and hot. In winters it's bitterly cold. But it was once home to one of America's most famous ancient civilizations.
It was a pair of cowboys that were chasing stray cattle that first rediscovered buildings in this area. And they were completely blown away by them. One described exploring the nooks and crannies of these cliffs as more exciting than hunting for gold, because you never knew what you'd find next. Wow. That is spectacular. It's absolutely spectacular. It's the scale. I don't know how many dwellings are here. There must be maybe nearly 100 houses. You can hardly see them in places because it's just the same beautiful colour as a rock. I mean, that's a small town, isn't it? Wow.
What those 19th century cattle ranchers uncovered was evidence of an extraordinary civilization, the Anasazi, or ancestral Pueblans, who made their home in this area for more than 7 centuries.
What's remarkable about this place is that the people who lived here didn't just survive in this hot, dry climate, they prospered. The dry conditions preserved all the trappings of a really sophisticated culture. Things like traded goods and farmed corn kernels, beautifully woven cloths, and intricately patterned murals and pottery.
At its height, as many as 10,000 people lived in beautifully crafted houses across the region. The secret of the Anasazi's success was their ability to exploit and control the scarce water resources in their desert home.
You know, for all the beauty and sophistication of this site, this is the real heart of it. This is the spring. Out there, when the rains come, they come in sudden deluges, and they're gone in an instant. But above here, when the rain falls, it trickles down through the sandstone rock until it